Welcome to another video on my Arduino Yun and breadboard with electronics and two motors of fischertechnik with propellers. Last time I added a second potmeter and changed some code with the idea that this potmeter regulates the speed of this propeller, and this potmeter regulates the speed of this propeller. Well, motor of course, but you get it, I think. However, there turned out to be a difference, because this potmeter is stepless and this potmeter is not. So let's first check if everything is working, still working. I do it once again using an SSH connection. So here it goes. And now things should work, and the same should be with this propeller as well, which is not the case. So let me carefully try to alright, and this is strange, very strange indeed. Because I am turning the left potmeter, and as you can see, it also influences the right motor, which should not be the case. So let me do something with the right potmeter at maximum, and that is not doing anything. Alright, turning this potmeter again to maximum, and giving alright, and this is not doing anything. So now the very big question is, oh, that is remarkable. The right potmeter indeed influences the right motor. I turn it completely to the left, it runs, and now I press the switch. Alright. And yes, it all works. It all does work. And now everything is over. So things work, just not exactly the way I expected it to do. And this also raises a question, because with this potmeter I thought to notice that turning it through the middle, like it is now, and then further to the right, the middle seemed to be a neutral point and not a midway. So I need to check on that. The question is how, and I think I need a multimeter for that. And if you've watched my videos before, you recognize this multimeter. Anyway, I'm going to check if my ideas about this potmeter are correct, and then see if I can actually recode into some different behavior in the motors. In an attempt to get to know more about potmeter, I tried to find it on internet, which I didn't manage. So now I have set this multimeter to measure resistance. Let me see if I can turn the camera a bit. Yes. So now it's at maximum, or almost maximum resistance. When I touch the other probe, it goes to 0. So now this potmeter is at neutral, as I understand. So let me measure one of the wires. Well, it is connected to, one is connected to ground, so I don't have to measure that. The other one is connected to ground, to power. So it is only the middle one that I have to check. And that one says now there is just very little resistance. So let me do an attempt in turning this potmeter. One way maximum. And okay, that was wrong. But it shows completely maximum. It shows the absolute and complete maximum now. And I slowly turn it around. And even one small step is already changing the complete resistance. So let me change from ohms to kilo ohms, which is the scale above and which has infinity on the other end, but I will have to change here to 1 kilo ohms now. So here goes. Now it says some 100, no, not even 1 kilo ohm, it's 800 ohms now. Now it goes to this is 100 ohm, 500, and maximum is, now here it goes back again. I know it's not very good lighting, let me try to change that. So turning the potmeter does have effect, but it also shows that neutral, or almost neutral, is a bit odd. This is maximum left. There, I pull it again. Not needed. This maximum left. And this maximum right. And so this is indeed not exactly the same potmeter. This is kind of balanced potmeter. Can I use it then? Not quite sure. What I want to do is just test it again and see whatever happens. So let's just do that. So now that I have determined it is actually or probably a balance potmeter, let's see if that substantiated by tests. Again, this one, the right motor is activated. Now I am going to turn this potmeter to the right, and it stops. Oh, that's because there is no data anymore. And let's see, now it is in the middle, and now it's completely off balance, so that is nothing spectacular. Going to the left potmeter, which as said is I have to keep the input in mind. Now it is at minimum, the left potmeter, about halfway now. So what does this motor do? Nothing. And that is a bit odd, because last time it just started running, but then also the potmeter was at its maximum. So this doesn't do anything, and this doesn't do anything now. Too bad that this motor is not completely automated starting. At this speed the switch doesn't do anything. Alright, left potmeter about half now. Pressing the switch. Nope. And this doesn't do anything now. And again I lost track of the input. And that is nice to see that pressing the switch stops the motor. Now I put the balance potmeter totally to the right. Some more input. Now what does this do? Nothing at all. And I put the right side, the balance potmeter completely to the right, to the left. The motor runs, and I turn it. Oh, that is remarkable. When the right potmeter, the balance potmeter, is totally to the left, it runs. Then at balance middle it stops, but at the right it doesn't go. It only goes at the left. That's remarkable. So it's not really balanced then. And when do you start? Some more input. I'm pressing the switch, and we do this then. It stops. By sound it runs at maximum. Pressing the switch makes it stop. But I'm also more interested in the right side, and Does it stop then as well? Look at this. I'm pressing the switch. And the motor actually gives jolts. So when it gives jolts and I turn the potmeter up, what happens then? It starts. I press the switch. Once again, input. So its behavior is not entirely consistent still. And once again, no input. Yeah, it's not entirely consistent, unfortunately. But it's a nice experiment, and I want to do something with pulse width modulation again. So let's go to there. So, time for pulse width modulation. Now, the problem is that, as you have probably seen in my previous videos, information I want is hard to get. So far I have disabled this type of setting pulse width modulation and use this one, although it is still not clear. The only thing that is clear that I have to use timers 0, 3 and 4. Those timers don't give an error when I upload. So I can also use these. The only point is that with timers 0, 3 and 4 I do not know which of the pins there really are. So is this indeed 13? Is this indeed 3 and 5? Is this indeed 6? I have no idea. And also, according to the information of the Yun, the pins that are missing right now are 10 and 11. Oh, and 9. So let me put a comment here. Pulse width modulation. Yun pins 3, 5, 6, 9, 10, 11, 13. Yeah, and those are missing here. Well, with a couple of them. So that is a big question and I haven't been able to solve it yet. What I am going to do now is disable this part of the code. Now, if this prescaler is the same thing as on the Mega 2560, then this is 30 Hz. And these motors that I use should be in the frequency range of 100 to 200 Hz. Well, that has been proven not to be entirely correct, but what I can do from some information I got sent is that I can use either prescaler 4 or 5. So I am changing this now to 4, which should be 120 Hertz, and that is already set here. So now the very big question is, what is happening? What will happen? And the best thing I can do now is actually checking things out. No, I will take out these two, use only timer 0, and then measure some frequencies. Although that's not, yeah, the point is also that I only use certain pins as an output, and those are 3, 4, 5 and 6. So 4, and that is an oops probably. That is most certainly an oops. I can't control this LED by pulse width modulation because it is not a port. So if so that's one thing. The 3 is now attached to the second motor, so that will be good. 5 is the switch, so there's no use to control that one because it's input, not output now. And let's see, no, that's 5. 5 is output, 4 is yes, and 6 is the input to this circuit. So is it better to put this on a different port? Most likely yes. Which port? Well, which port is listed here? 6 is used, 9. So I probably should change this to 9. Or this one from 4 to 9. I think that's a very good idea. And where do we do that? Output pin 4, right here. So 4 becomes 9. And 9, oh, 9 is being used here. Is it used? Nope, it's not being used yet. So this was here already, I guess. Let's get some programming done then. And hardware change. Alright, I have rerouted this wire to port to pin 9. So let's upload start and see whatever happens and measure a frequency which should read right here 12 because of this frequency. So let's oh yeah, and of course I did change 4 into 9. So let's hope there is no compilation error. And yes, I'm uploading, so I have to give the password. Yes. Right, now I have to go here again with password. Give some input, And now the point is that I have to measure right here, and I have to press a switch. Or do I? Well, it says now 120 Hertz or something. Oh, I have no input anymore. Right now it says 20 Hertz. I turn up the volume. This is a better view. So it's out of characters again. I have to keep in mind not to touch the propeller. Can I influence? Well, it varies enormously. So actually this is changing the speed by voltage. And it is now some 120 Hertz. But is it really? And this one is connected to port 3. And is it 120 Hertz? Yeah. Go. This is about 180 Hertz. 200 Hertz. I am in the light, but so is this proof that it works? Well, the difficult point is of course that I have disabled timer 3 and 4. And it's a pretty big gamble which one is which, because on the Mega 2560 it was not logic. It was to me not logical which was which. No. Yep. I need this one to give input. So, did I succeed for pulse width modulation? Well, it certainly works. That is something that's clear. But how does it work? I can't answer that one yet. I'm not giving up on that one. So let's do one more attempt. Once again I'm puzzled. I did some new search on the timing registers for the Yun, and it says there is 0, 1, 3 and 4. And another thing that says, well, you can only use 1, 3 and 4. Yeah, 1, 0, 1 and 3. So what happens if I say DCC R1B I have no idea what this, what the implication is, what I'm doing now. I'm just seeing if this has a compilation error, and it doesn't. So indeed all 4 are correct. Question is, which one does which? And right now I have no clue. Done uploading, very fine. I have to enter this one again. There we are. One motor going, and this one as well. Alright, so this gives even more info to find out which is which, and that is what I am going to leave you at for now. Pressing the switch diminishes the speed. This is a balance potmeter. This is a normal trapless potmeter. I rewired this from 4 to 9 in order to have it on pulse modulation, and rewiring of course to another pin on the Arduino, to nowhere else, and then a frequency that seemed to go like 120 Hz like desired, but did I measure it on the right port? I honestly have no clue. Anyway, that's it for now. Thank you for watching. If you like this video, please subscribe to my channel. Also follow me on Twitter and Instagram. Please be so kind to make a small donation to keep my blog and website going and my videos. And more info about donation, please see my website, also for my other projects. And this is certainly to be continued. So, bye bye for now. Stay away from the camera.